We're back again, Molly.
Erase the bottom.
The eternal class. Alright, I'm going to erase part of this. I've got the 1700, I can use it. Or not. Okay. I'm going to change this problem in one aspect and ask the same question again. And guess what I'm going to change? It's no longer going to be at rest. It's going to have an initial velocity. So I'm going to give it initial velocity of 4.2 meters per second. So V sub O is 4.2 meters per second. This is going to change our total energy because it no longer is starting at rest. It has kinetic energy. So how do we calculate total energy now? So that's my first part. I'm going to ask again, find the velocity at B. Do you think velocity is going to go up or down with this new scenario? It's going, because it has an initial velocity here, it's going to end up being faster when it gets here than if it had been just still and fell down the hill. So let's go ahead and calculate this again with the new scenario. The initial velocity is 4.2 meters per second. We start by recalculating total energy. Total energy at point A is mgh at A. And that's where we stopped on the last scenario, but now we have to add the 1/2 mv squared at A. So go ahead and calculate that at point A. Make sure the difference between those two ideas, the first problem and the second one, is clear before you leave me.
Why are there so many 4.2s?
Yeah, you have a point there.
Using
Sorry.
And 42s.
yeah, 42 and 4.2 everywhere.
Or
I'm just gonna check this to make sure.
This is a book of a 4.2.
As you calculated, mgh at A was probably already calculated somewhere on your page, or you could recalculate it. Then you get to 1/2 mv squared.
Math book out. All the problems use the exact same number.
We know all of these numbers. Have you got them tapped in? All right, tell me when. And again, I haven't checked mine, Sue. In fact, I don't have mine again, so you have to help me. All right, who has a number to bounce off? Aaron?
2100.
Anyone?
Yep.
That's right.
All right, and again, we're in joules because it's an energy. All right, if you put in the numbers, 42, 9.8, 4.2, 1/2, 42, velocity was 4.2 squared, and did that correctly, you would get 2100, 2 sig figs. All right, cross out. B1.
Bingo. Oh.
Oh
Yay.
my goodness. There's one.
Right, write that at the top so you know.
Wait, do I just say bingo on top?
This class.
Yeah,
I'm gonna
right,
be so
right
sad.
bingo up top, so
No, I
I'll
won't
count
believe
that.
it.
I think all the things I need
I
have been
know,
called.
like all of them fit in.
All right, continue. We're going to find the velocity at B again. So when we go over to B, we go total energy equals mgh at B
How many more
plus
problems are we doing?
1/2 mv squared at B. We're looking for velocity.
It's the same.
We know everything now. Total energy is the same at every spot, and we just calculated it. So we know everything except V. Tippy tap away.
So it's the same cart.
Yeah, same part. Yeah. Uh-huh.
I kind of fell behind you for a second. So when Megan got like, you said 6.7, I don't know if I got 6.1.
Yeah, let's see. You got the that. and there's a plus sign, do you see that?
Yeah, I did.
Okay, 1/2 mv squared, that looks healthy. And,
That, so that's 740 for that, and then subtract them down the side.
alright, well this, so you're solving for v, right? And this number, did it appear anywhere? That should have been right there, total energy.
Yeah, no, okay, when I look at
Alex,
this,
I just
it
wanna
was
go play that game.
Okay,
I put it on like this side, so I did that right.
okay.
Did you do any more than I had that?
No, I went home.
But
I
is this
watched
number
it,
or
I was
in
like,
this
what's wrong?
somewhere? Is that number in
Is
this?
it fine?
What'd you get?
We found the
Because it should be
velocities. We're given the velocities at
1700
point A up here.
equals
And it's
this
gonna just
number
kind of
plus
drift,
that
and
v
then it's gonna come
squared.
back up
So I
to
don't think
point
you
B.
have
You can't
that.
add these together first. You have
Oh,
to
do I have to
subtract
subtract
from
it
the
first?
side
So
and
you're
then
saying
divide by
this
that.
times this times this is
No,
740,
that was when it
right?
wasn't moving up here. Now it's moving,
740.
so it'll be different, like it'll drift more.
Alright, and this should have been 1700 here.
That was a
I don't
completely
think
different
you
problem,
have
just
that.
very, like, the same
We
numbers.
calculated that right
But
here.
now, this
Right here.
part.
Oh, see, you had it.
Or this part wasn't moving, but now is moving.
So, I'm not sure why. So total energy we calculated
Oh,
earlier.
right here, oh, you did it right
Like,
here.
we got this one,
Okay.
Yeah.
and we just.
Alright. I got a V, would you see if my V is, I got 8.0.
Yep, that's what I got.
Yep.
Alright, you may cross out, there's not much.
I don't get bingo this time.
05.
Miss Powell. Bingo!
You're kidding me.
Alright, put another bingo up there.
What was it?
Alright. Draw a box, we're gonna kick it. Frustrations are gonna leave as you pick the box. Kick the box. Draw a box and kick it. We're gonna kick it across a table, or I guess across the floor, and it's gonna take 4.8, it's gonna be kicked at 4.8 meters per second. The box is 2.5 kilograms, and it's gonna come to a complete stop. I wanna know how far it will go when the kinetic coefficient is 0.42.
Oh, goodness.
How far will it go?
Okay.
I'll give you the force of friction formula. Force of friction, mkmg. He comes out to play on this one. I'll give you a clue. You start with the work equals force times distance. And the question was how far it will go. So we need an x. And here's the x that you're going to solve for.
Wait, do we have the
All the work is kinetic, so you're gonna put in a 1/2 mv squared.
Oh.
All the force is all friction. And the distance is what we're looking for. So we should know everything. And you can shorten your work a little by crossing out m. If you leave it in, it'll be the same. Yes.
I wasn't able to finish up the
Oh, yes.
number for this.
Any left there?
So I was confused, so how,
Yeah. Let's write down total energy equals potential energy at B, right, and plus kinetic energy at B. Alright, now, we already calculated total energy.
total energy.
Yeah, 1700 equals mass is,
42.
G is 9.8, height is plus 1/2, mass is Again, 42 times b squared. So try solving for that.
You know when you get little stars
Yep.
in your eye?
Okay, so it's just last.
Should be fine
And
now.
it hurts. I used to do them all the time, but I haven't gotten them in a while.
All right, there's a couple problems I wanted to go over before the test. So may we take a portion of, what's today, Wednesday, Thursday, and finish my review? And then begin the test a little later in the day and finish it on Friday? Will that work?
Wait, so we're moving the test.
Not
Tomorrow's
really.
Thursday.
Yeah, we're gonna still start it on Thursday.
Feels like
I know, we're all mixed up. There's like 3 more problems I feel like you need to review before we take the test. So when you come in tomorrow, I'll review, clear up any other last minute questions. If there's another problem you type you want to practice, we'll begin the test sometime tomorrow. So come ready. Don't delay it because we're going to continue our review. Study the green sheet, the yellow sheet, your comp book, study it all, and be ready to start that test tomorrow. All right?
Are we gonna say the answer for the one you just gave?
Yes.
Okay.
Okay. All right. So when we did it, how far? Did anyone get what I got? I can't read my writing, but it looks like 2.8.
Yeah. Yeah.
2.8 meters. All right. You may cross out I-4.
Oh, finally, bingo.
Yay.
I still.
Yay,
Okay.
bingo!
What did I say? I
I got bingo.
4.
One bingo.
Okay.
I still
Ghost
have
bingo.
bingo.
Molly, did you hear that? We're going to review a couple more problems and then start the test tomorrow. Hope you're with us. Bye-bye.